Varthini Rajagopal. I'm working as assistant professor in Carmel College of Engineering, Sreerangam. And in today's session, we are going to talk about systematic literature review, scientometrics, and meta-analysis. So at the end of this session, we'll be able to have some idea like how to develop these kind of text mining, visualizations, these kind of networks, like how we can gather data from a huge set of literatures, say for example, 1,000 papers. From 1,000 papers, how we can gather or synthesize meaningful data and visualize them in a network format. So these are some of the takeaways we are going to see from this session. So today's session will be discussing about what is systematic literature review, what are the steps involved in a systematic literature review, how we are going to extract the bibliometric data, then visualize those data, and from the visualization, how we are going to get a meaningful interpretation. So we are going to see different types of tools we are going to use for that above steps. And finally, we are going to see a glimpse about the meta-analysis, and we will close it off with what are the available softwares that can be used in scientometrics. Right. So why scientometric? Why systematic literature review? We are very much comfortable with narrative review. So for the past, in the past, as a research scholar, even I started with narrative literature review. The problem is the narrative literature review cannot be replicated. That is, if as an author, I am going to choose a research domain, and for example, it can be narrative manufacturing. Okay, in that domain, I am going to have a set of keywords. I am going to have a preference. For example, my search engine can be a web of science, or your search engine can be a science direct. So each author will be having some bias. So he will be producing a literature review based on his experience or whatever data he is familiar with. So when I try to replicate whatever the author has done in a narrative literature review, I won't be getting the same inference. Okay, so he might have concluded that this particular domain is going to be the upcoming area based upon his biased research. When I try to replicate the same, I won't be getting the same result. So that's where the systematic review comes into picture. Systematic review is not a new stream or a new tool. It has actually been in existence from 1950s. Mainly it is available, mainly it is preferred in medical industry. So if you are going to write a paper, research paper, specifically in a literature review stream, if you are going to show preference to the systematic literature review, the chances of your paper getting accepted over the narrative literature review is very, very high. Also, most of the recently, even in the mechanical research domain, many journals have changed their policy to accept only systematic review rather than the narrative review. Okay, so how systematic review differs from narrative review? So in systematic review, you will be having a clear, transparent process. Okay, so how you are selecting the studies for your review, how you are including those studies, why you are excluding some other studies. You have to be very, very transparent and very, very clear about it. So that even another author X or another researcher X, if he replicates your same research process, he has to get the same data. So this is very, very useful in minimizing the bias. As you know, as a researcher, what I tend to do is I tend to cite my friend's paper or my guide's paper or my whoever's closer to me. So that is the bias I'm talking about. So as a researcher, I will be having a I will be having a set of academic friends whom I prefer to cite or whom I prefer to get the data from. But that bias is removed in your systematic literature review. So that is how the narrative and systematic literature review varies. And as I was saying, if you write a paper, literature review paper systematically, then your chances of your paper getting accepted is very, very high when compared to the narrative review, where you will be just summarizing what each of the individual author has contributed to the particular domain. Right. So what are the types of literature review? So I have talked about narrative and systematic. So as of now, the researchers are moving from narrative segment to the systematic literature review. So what are the future scopes? So systematic review can be combined with meta-analysis. If you are going to combine your systematic literature review with meta-analysis, then your paper will be having a 100% chance of getting accepted, because that's a very, very rare case even in the medical field. So what meta-analysis. So what we are doing is, maybe we are collecting 100 papers. From those 100 papers, I am getting the inferences, the results. Then I am doing some statistical analysis, and without doing any experimental work, just based upon the findings of those 100 papers, I am actually giving a new finding. I am strengthening the finding of the 100 papers. I am consolidating the findings of the 100 papers using a statistical method, and I am presenting the result. So that will be very, very powerful. Next is scoping literature review. So that is much broader. That is, you cannot do it for 100 or 150 papers. It should be a broader segment. For example, I cannot go with the fused deposition modeling technique alone. I have to go with the entire additive manufacturing. So the number of papers I'm going to review, it should be very, very large, more than 200 papers. Only then I can be able to answer what are the upcoming domains, or what are the domains that have been saturated, which research area can be studied, like those kind of broader topics. And finally, we have the integrated literature review, where I'll be combining the qualitative and quantitative data. So as of now, the research focus is being currently in systematic literature review. So I'm repeating again, if your work can combine the systematic literature review as with the meta-analysis, then the chances of your paper getting published in the SCA and top SCA journal is very, very high. Right. So we have seen how impactful the SLR is. So let us see what is SLR. So SLR, it has only 4 simple steps. You are going to locate a set of papers. Okay? You are going to locate a set of papers to review. Then you are going to extract the data from those papers. You're not going to read. For example, when I say you are going to review 200 papers, it doesn't mean I'm going to read the 200 papers from end to end. I'm just going to extract the data from the papers using some bibliometric tools. Then I can synthesize. Okay, so I'll group the papers which have having some commonality. Okay, then I'll synthesize those data, and then I'm going to visually represent those data in a such a way I can have my research questions answered. So these are the 4 steps, and how it differs from narrative is, if another author, say an author X, he is going to replicate whatever you are doing or whatever you have done in your SLR paper, he also should get the same answer. So your methodology should be so transparent, it should be so open and detailed in such a way anyone can replicate and get the same answer. Right? So what is the output of SLR? Actually, we should start with a set of research questions. Okay, whenever you start with a review, you should have a purpose. Why we are reviewing a particular domain? You should have some research questions in your mind. For example, I am trying to review an additive manufacturing domain. Then I should have set of questions like, what are the saturated areas in additive manufacturing methods, or what are the upcoming areas in additive manufacturing methods, or what are the predominantly studied techniques in additive manufacturing methods, what are the materials like composites or polymers, or it can be metal, what are the materials that have been predominantly studied or characterized. So I should have set of research questions before proceeding with the review, right? So that is the first step, formulation of your research questions. So your SLR report should answer those formulated questions. Okay, it should identify key scientific contribution. It can actually give you an inference about the bibliometric data, like what are the publications, what are the keywords, who are the authors, which country has contributed much to that particular domain, or which author has contributed much to the domain, what is the frequently used keyword, who has been cited a lot, or which author or which paper has dynamically changed or revolutionized that particular domain. So these kind of outputs can be obtained from the SLR. So when you combine these outputs with meta-analysis, they are going to be more impactful and powerful. Right. So this is one of my systematic literature review paper where I have formulated the methodology. So as I was saying, there are 4 steps. The first step is you have to formulate the research questions. So I will tell you the techniques that I used to formulate, but the first step is the formulation of research questions. The second step is locating the studies. So this step is closer to you, like whatever you are comfortable, but you have to mention how you are including certain studies and why you are excluding certain studies. For example, in this work, I have included only the AJG, that is Academic Journal Guide. So the Academic Journal Guide is it's an institution that actually ranks the journals. So they rank it they give a rating like 4 star and 5 stars. Okay. So I have included only those journals rated above 4. Right. So like that you can have some inclusion criteria, but you should clearly mention those. Okay. So from those inclusion criteria and with a set of keywords, I had gathered 538 articles. So this is my initial data. Okay, so I have located 538 articles. Then I am doing a preliminary screening. So I'm not going to read the entire 538 articles from end to end. Okay, so this 538 articles I'm going to further refine, and I should be very clear about what the exclusion criteria should be. So here my exclusion criteria is I will be reading the abstracts, keywords. Okay, if they are I have read the abstracts and keywords of 538 articles, and they should be suitable to my research questions. Okay, so they should have at least one specified keyword in that abstract or title or keyword category. So based on that, I had finally had 344 articles. Then from this 344 articles, with the further exclusion criteria, I had shortlisted 126 articles. So let me repeat again. So if an author X is going to replicate the same process, he also should have 126 articles at the end of the phase 2, that is step 2. So this 126 articles I am going to systematically review and answer the set of questions I have formulated. Right? So I have gathered the 126 articles. Then the third step is the data extraction, synthesis and visualization. We'll see this third step in detail. Okay? And finally, I'll be getting the results. So based upon my synthesis, I will be answering the formulated questions. So this is the generalized step of the systematic literature review. If you have any questions in between, please feel free to ask. Yeah. So I was saying, like, how do you formulate the research questions? There are actually a lot of techniques to formulate it. The predominantly used are SIMO technique, PICO technique, and PRISM. Okay? These all three are evolved from the medical field. So the words mostly they refer to the medical practicing words. Okay, so SIMO, PRISM, and PICO. So we'll see the 2-1. The SIMO. This is what I used in my systematic literature review, the one I showed in the previous slide. So SIMO stands for context, intervention, mechanism, and outcomes. So context is in which system you are going to study. Okay, so if you consider medical field, it can be a women category for women of age above 60 or women between age 35 to 60. Right? So in case of mechanical field, it can be a context related to, say, for example, I'm going to study about friction stir welding. So what system you're going to study? The intervention is what are the inputs and what are the outputs you're going to study about. Okay? So what input factors you're studying and how you're going to determine the output factors. So that is intervention. Mechanism is what is the relationship between the inputs and the outputs, like how the input is going to affect your output. Okay, and outcome is what are the ways you are going to measure the output. Like for example, say I'm going to study a friction stir welding, and in that process the rotating tool speed, the rotating tool speed will be having some effect on the surface roughness, right? So what is the effect of the rotation speed on the surface roughness of the final weldment? So those are the measurable outcome. So like this, you can formulate the research question. Each research question should have these kind of points. Like for example, what are the predominant? So I will give an example of a research question in case of friction stir welding. What are the predominant inputs that is going to affect the surface roughness of the weldment? Or what are the predominant inputs that are going to affect the surface quality of a weldment? So like that, you can formulate research questions. Then based upon reviewing the 200 articles, you can answer the particular research question. Or it can also be like what are the dominantly studied material, or what are the predominantly studied material in friction stir welding. Right? That is also a possible research question. So like that, you can use SIMO logic to formulate a research question. Right? So this is the questions I had formulated. So what are the basic research concepts in supply chain diversification? Okay. So here my domain is are the inputs. What are the most supply chain risks addressed? What are the mitigation strategies and models studied? Okay, so these are all the inputs. And my output will be what is the relationship between these inputs over the risk reduction. Okay, like risk measure, decision makers risk attitude, modeling techniques, etc. And outcome is how to quantify decision makers risk attitude. So like these you can formulate a research question. So I have formulated the research question using SIMO logic. Similarly, you can also use PICO. So P stands for patient. As I was saying, so your patient will be a woman of age between 35 to 60, or it could be a problem, or it could be a domain or a population. And intervention. Intervention is what are the techniques. Okay, so differing from SIMO, here we'll be seeing the various techniques. What are the techniques you are going to use? For example, if it is a medical field, what are the drug intervention, what are the surgery procedure, what are the different types of techniques you are going to use to bring down that particular disease. Okay, so if it in case of friction stir welding, what are the different modifications that has been done to the tool so as to improve the surface quality of the weldment. So this is a comparison. Okay, so this is various different types of techniques. The third one is C, comparison. So here we will be comparing the outputs of the various techniques. Okay, what is the alternative to the current existing technique? That can also be called as a comparison. And finally, the outcome is the same as the previous one. So here you should be having a measurable outcome. So inclusion criteria. So how you are going to locate your studies? So here you will be having a you should have a clear definition of why you are including a particular paper inside your review, right? So it can be from a particular database like Web of Science. You can be very specific. I want to use only SCI journals or emerging SCI journals or Scopus Index journals. Right? You can specify those. Then from those databases, you have to identify your research papers using keywords, right? So you should be very specific, like what keywords you have used. Okay, so these are the inclusion criteria. I'm going to include only the articles that are published from 2005 to 16. So once you have the initial database, say for example the 536 articles I had, from that you have to exclude. So exclusion criteria can also be of your own, but it should be explicitly stated. Okay, why you are excluding those. So let me be clear again. You're not going to read those 536 articles from end to end. What you're going to do is you're just stream through it. You're just going to look into the title, article, title, abstract, or keyword, and then you just make sure that article is suitable for your review process. Right. So we have done the research question formulation and locating the studies. Moving on to the very important phase, that is data extraction and visualization. So here's where scientometrics comes into picture. So scientometrics is nothing but it's a field of study where you will be using the bibliometric information to create or visualize how the research has shifted, the paradigm has shifted or evolved over a particular time. Okay. So what is bibliometric? So bibliometric can be anything from the author information, the journal title, the country in which the author has published, or the institution, his institution, or the year of publication. Those kind of data will constitute the bibliometric information. So we are going to extract those data from the paper, and then we are going to visualize and synthesize the data. So from the visualization, we are going to answer our research questions, right? Yeah. So we'll be extracting the papers from the database. Then we will be analyzing. I'll be stating what are these. Okay, and we'll be finally answering the research questions. Yeah. So what are the popularly studied scientometrics? We have the bibliometric analysis. So under bibliometric analysis only we have the three types: the citation, bibliographic coupling, co-occurrence analysis. So co-occurrence analysis, this is an undirected network. Okay, about two are directed networks. That is, A will be related to B. So from A, B is related. So direction will be provided. Whereas in case of co-occurrence networks, it is an undirected network. There will be no direction. You will see those in detail. So I was saying bibliographic information. So bibliographic information can be the journal in which the particular paper has been published, the title of the paper, the author, his address, that is the institution in which he is working or the country he is actually from, the abstract, references, and even the citations. So how many papers we are going to do that. So let us stop with some of the narrative. We'll see a demonstration using Web of Science. Then we'll come back to these network analysis. Clear? Okay. So I will be explaining you how to extract the how to extract the bibliographic information. So my preferred data, my preferred search engine is Web of Science. If you are also using Science Direct or Google Scholar, that is also fine. But if you are using Science Direct or Google Scholar, make sure you have a PDF manager like Mendeley, Zorito. So that will be very useful in extracting the data. So Web of Science is pretty simple. So that's why I prefer this. So I will just say how I'm going to extract the data. Right? Yeah. So let me. So I'm logged in into the Web of Science and I'm searching in documents. I'm going to advanced search, right? So I'll change the all fields to topic because topic it will search the papers across the abstract, keywords, and title, right? So I have already written my query. So what I'm trying to do is I'm trying to search papers related to 3D printing, that is fused deposition modeling. In specific, since I want to have a keyword data set so that I can visualize it easily, I'm going to search paste extrusion process. Okay, that is a very new domain and very few papers have been published over it. So first I have included the keyword, that is the first set of keyword is pertaining to the FDM. I'm adding that. And my second set is paste because I want to focus only on this technique. So I'm adding that to the query. Right. So let me clear it. It's already there. So let me start from the beginning. Topic and to query. Then I want to search papers pertaining to the paste FDM techniques. So I'm gonna add that query and then I'm searching. So I found 44 papers. So that's why I wanted to limit, because if I had searched only the FDM, I would have gotten 20,000. So since I want the visualization to be much easier, I have gone with a newer research domain, that is paste extrusion. Then you can actually further filter it based on your year of publication or what type of articles you want. Okay, I will leave it to that. Now you have an option here, analyze results. Okay, click on it. In analyze results, you have the option of getting the bibliographic data. For example, I can get the publication year. So in which year the papers have been published, and I can also have the frequency, right? So let me get it in the sort by result count, right? So initially I showed you data mining, text mining, right? So this is, so out of 44 papers, 9 papers has been published in 2020 and 6 papers have been published in 2021, 4 in 2023 and 4 in 2025. Okay, so if you don't want a tree map chart, you can also have a bar chart where the data will be completely given. Okay, and you can also have the entire data in the below. Right, so this is the first bibliographic information, that is the publication year. I can also get the author's name, right? Research. Yeah. So you can have a maximum of 25 only. Okay. So this is a research count. So around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Only 11 authors have contributed to this research domain twice. Remaining, we have only one authors. Okay, so by looking at this, you can also have an idea of possible collaboration. Suppose you are going to area, as I was saying, is very, very relatively new. And if you want some collaboration, you feel that you need some support, you can reach out to these authors because they have already contributed 2 papers in this domain. Right? And if you want to know some other data like the country, right? In which country they has been published, it also is available. So US is contributing a lot towards it. We have Thailand, Russia, and yeah, in India also there are 2 papers. 2 authors have contributed to India. So these are the bibliographic information I'm talking about. And if you want to know the funding agencies, because if you are interested in procuring funding, that also you can do. So these are the funding agencies, right? So like these, you can get the information that you require. Okay, right? So I have extracted the data. I'm sorry, I have located the studies. Now I'm going to extract the data. So that is how we are doing the text mining. So that is one technique. So if you are including these kind of visualization in your review paper, then it will be more attractive. The chance of getting published is very, very high, right? So let me get back to my search. So I had 44 papers, right? So I'm going to extract the bibliographic information from these papers. So what I'm going to do is click on export, choose RIS format. Okay, so it is actually asking which one you want to extract. That is what information you want to extract. Whether you want to extract the author, title, source, abstract, or full record. What it means by full record is you will be extracting the author information, title, journal information, abstract, keywords, the cited, who are all cited this paper, and also the reference list. Okay, so we need all this for our data visualization. So I'm clicking on the full record. So I'm extracting it. Remember, I'm extracting in the RIS format because the tools I'm going to use, it supports the RIS format. So I've exported. Right. So till now we have seen about SLR and the steps involved in SLR. In particular, we have seen how we are going to locate our studies, how we are actually extracting the studies from the database, right? So let me come back to my presentation. So I have extracted, we will see how to visualize a network using these data. So let me come back to the my presentation. Yeah, so I've been keep on talking about visualization, data, co-occurrences, bibliographic updates, etc. Right? So let us see what those are in detail. Okay. So here, generally a network, it represents a connectivity, right? So each node will be an actor. Like it can be an author, or it can be a paper, research paper itself, or it can be a country where it has been published. So each node will be, it carries some information, right? It is an actor, and these node will be connected to another node if they are linked, right? For example, this is my research paper 1 and this is my research paper 2, and they will be connected if they have a common keyword. Okay, so or this is author X and this is author Y, and they will be connected if they have combinedly published a paper, right? So this is how I'm going to create the network and visualize my information. So as of now, just get it. There will be nodes, and the nodes will be connected by means of edges, right? Yeah. So citation network. I was talking about citation, right? So as I was saying, citation is a directed network. That is, for example, each node will represent a research paper, right? So paper A will be connected to paper B if paper A cites paper B. Okay. Paper B will be connected to paper C if paper B cites paper C. So like this, I'll be forming a network. If one paper cites another, then a connection is established between those 2 papers. So that is citation, right? Let me talk about co-occurrence. Okay. Co-occurrence networks, I will talk in detail. Yeah, this is an example. For example, so as you can see, this is a directed network. That is, each node is connected to another with an arrow graph, right? So what it means is, Agarwal, this paper Agarwal has been cited Faisal 2006, he has cited Manoj 2008, right? Like this, you are forming a directed network. So here the edge doesn't carry any weight. If a particular paper has cited another paper, a connection is being formed. So it is a directed network. So this is how we can visualize. I will tell you how the tools used to visualize it. But this is how you form a network. A connection will be established between two papers if a particular paper cites the another paper. Now, co-occurrence or co-citation. So this is an undirected network. So how that connection will be established is the paper A and paper B will be connected if they are both cited by some papers. Okay. The connection will not be established if paper A cites paper B. The connection will be established between A and B if there are some other papers that is citing both A and B. So in this case, it will be an undirected network and the edge will have weightage. For example, here 1, 2, 3, 4. 4 papers have cited both A and B. So the edge weightage will be 4. Okay. So more the edge weightage, more will be the density. You get the concept. So co-citation, whenever you use the word co-occurrence, it means they have something in common, right? So A and B has a common co-paper citing both. Okay, that is co-occurrence. Whereas in case of citation, H will be established if particular paper cites another paper. Okay, they don't have any commonality here. No common papers are citing both the journals. Okay, that is citation network. Whenever you have co-citation, it means these two papers has been cited by these 4 papers. So a link will be established between 2 papers if there is a common 4 papers that cite both A and B. Is it okay? Yeah. The reverse of it, bibliographic. So here what happens is the link is formed between A and B if they have these 4 papers commonly in the reference. Okay, this is the reverse. So what we saw is the forward effect. That is A and B is being cited by these 4 papers. This is reverse. A and B will be linked together or coupled together if they have these 4 papers commonly in the references. Okay, this is reverse snowballing effect. And the co-citation is a forward snowballing effect. Yeah. We also see some other co-occurrence network like keyword research focused parallelship networks. We'll see what those in detail. So research focused parallelship network is you will be having 2 papers and these papers will be linked if they have a common keyword. For example, in paper 1 I am having the keyword FTM and in paper 2 I am having the keyword FTM. Then a link will be established because I have a one common keyword. So more the number of common keywords, more will be the edge weightage. Okay. And in case of and in case of keyword co-occurrence, okay, keyword will be the nodes, okay, and a link will be established if there is a paper that carries both the keywords. Okay, for example, this is FTM and this is space FTM, right? So I have 2 keywords. K1 is FTM and K2 is space extrusion. So they will be connected if there is a paper that carries both the keywords. Okay, that is co-occurrence networks. Similarly, we also this is what I was talking, the citation network. So these will be directed network. So A will be connected to C if A is going to cite C, right? And we have the co-author network. For example, the node will be authors. So this is author X and author Y, and an edge will be established if they have commonly co-authored a paper. Okay, more the number of co-authored papers, more will be the edge density, right? So we have already seen co-citation, bibliographic coupling. Yeah. So this is from my work where I had gathered that 126 papers. So these 126 papers have been visualized. Okay. So each of the node will represent the paper. Okay. The node ID 9 represents a research paper. And this research paper is linked to another research paper if they have a common keyword. So clear. So the paper 9 will be linked to 67 if they have a common keyword. So as you can see here, the density is very high compared to this density, right? So it means more number of keywords is there between these two. More number of common keywords is there between these 2 papers when compared to other papers, right? So this is research focused parallelship network, right? Then from we have seen what are the different types of networks that can be visualized, like co-occurrence, co-citation, keyword co-occurrence networks. So once you have visualized, how you are going to synthesize the data from those particular networks. Okay. So for that we have various techniques like cluster analysis, strategic diagram, main path analysis, latent semantic analysis, hierarchical clustering, and multi-dimensional scale. Okay, these are all not new techniques. Actually, these techniques have been in existence from 18th century, but the thing is, they have not been much used. So if you are going to write a review paper and you are going to plug these techniques, then your paper acceptance rate in Q1 journal is very, very high. Okay, so let me talk about cluster analysis first. Then I will give you a demonstration. Then I can come back to the remaining techniques. So that will be I will be narrating what are those techniques. Okay, yeah. Cluster analysis is right. So I have this 126 papers. Okay, I have visualized it based upon the strength of that is a common keywords between them. Right. So from this, I want to know, my first research question was, what are the predominantly studied research domains in supply chain risk mitigation? So I want to know what are the domains in this 126 papers. So for that, I'm going to cluster. I'll tell you how to cluster it. I'll actually demonstrate that. So I've clustered that particular 126 papers into 4 clusters, right? So I've grouped the papers. So how I'm grouping is the papers that have more density, that is more how do this? The papers that are closely related to each other, they will club into a cluster, and the paper which have relatively weak strength, that will move away from that cluster. Okay, so I have clustered them based upon the modularity index. So the meaning of modularity index is it will group the nodes that have stronger connection between them and weaker connection with the nodes outside the cluster. So like that, I have grouped the RFPN network into flow clusters. So what it means is there are 4 predominant domains in that supply chain risk mitigation research area. Okay, so once I grouped it, then I can determine what each of the cluster is talking about. Right? For example, I can say that this domain, okay, this domain has stronger ties to the other clusters. We can see the edges. This domain, all the actually the cluster 3, 2, and 1, they have stronger connections with the outside domains also. But this domain, cluster 4, it has very, very weak connection with other clusters. So what it means is this is a very, very this is in periphery, that is this is an upcoming area. So if you're gonna study any topic related to this cluster, then chances of your paper getting published is very high. Because I have found many researchers who have dedicated at least one to 1.5 years working on a particular research area. They will be finalizing the chapters for the thesis. Okay, they will be clear with that before starting. They will be very clear. Like, I want to work in this area. I want to do experiment in this area. Like, they will be very clear. But once they complete the work and then process the paper, that is where they will be having a huge question from the journal. Like, they will be saying this work has already been done, this material has already been processed, the characterization technique has been done. What is the novelty in your book? Because we are, as a researcher, we cannot produce something new day by day. You know that, right? So we have to focus on the upcoming, the outliers, the peripheral area. So the problem is how to find that peripheral area. We will be focusing on whatever resource we have in hand, whatever our seniors they were working. We will be making minor changes and we will be performing that experiment. For some modification, we cannot bring in new changes every day. We will do some minor modification and we'll see what is the impact of that modification. That is how, as a researchers, we go. So the thing is, when we submit our 1.5 year work to the journal, the first question will be, this work has already been done. What is the novelty in your work? Yes, we would have done some small changes, but that small change will not quantify as a novel contribution. They will be like, this is a very minor change. Why should I publish this? So this is a very minor change. It's a very, very small change. It doesn't have much impact on the output. So like that will be safe. So if you are able to do a systematic literature review, and if you are able to find out the upcoming domain, so here I can say that in supply chain risk mitigation, the work that has done in the coordination, pricing, and risk sharing contracts, it is very, very few, and So cluster analysis one, synthesizing data from which we can answer the question, right? So let me tell you how to do this cluster analysis. Okay. Let me go back to the data which I have extracted using Web of Science. So this was the data which I have extracted in RAS format, right? So let me save that. Yeah. So the tool first I'm going to use is PibExcel. Okay. So PibExcel, it is a very good tool in extracting the bibliographic information from this data set. It's a very simple tool. You just have to double click on it. It will automatically open. It doesn't need any extensive setup on everything. Right. So let me open that file. If you have any doubts till now, please feel free to ask. Yeah. So I'm clicking on the .ras format. So if I try to open it, it will not open. It is getting the error. First, we have to change it into different format, right? So go to this. Sorry. Go to edit.file and click on the replace line feed with cartridge written. Okay. If you do this, okay, now you will be getting the data. You have yet to condition it. Okay, the next step is miscellaneous. Convert to dialog box. Click on convert from RAS format. I've used this format, so I'm clicking on the convert from RAS format. If you have used different data sources, for example, Scopus or Science Direct or Taylor and Francis, okay, similarly you can use different process steps to format it. Okay, I'm clicking on it. Right. So this is my condition, or this is my processed data file. So if you look into the, it may expand it. If you look into this data, the first one is author. So I have actually 44 papers, right? So this data is about the first paper. Okay. So this is paper is written by Shastri Shans was. Okay. Then T1 represents the title of the paper. T2 represents the journal title. LA represents language. KW represents the keywords that are being used in the paper. AB is the abstract, and AD is the address. Okay, C3 is city. FU is funding agency. Then you have some other data which I have only. Right. You also have the citation count. That is, this paper has been cited 9 times, and in reference it has 25. So ER is the end of record. This is the record of the first paper. Similarly, you have the next paper's record. Okay. So the title of this paper is Design and Fabrication of Modular Supercapacitors Using 3D Printer. So like this, I have the data of all the 44 papers. So without reading, or without even opening the paper, I have extracted the important or needed data just by using the PibExcel. Right. So now I need to know, say for example, I'm interested in the journals. So which journal has been published? Okay. So the journal is actually T2, right? Click on, so type T2 in the tab. Okay. And here it is asking how to extract the data. Okay, do you want to extract the cited reference or any separated field, semicolon separated field? It means it can be a keyword, it can be a author information, etc. Okay, since I'm extracting the title, since I'm extracting the journal title, I want to keep the whole field intact. Okay, click on that. Right. So the first paper is being published in IEEE Transaction. Second paper is published in Journal of Energy Storage. So like this, I have the data of all the 44 papers. Okay, so let me repeat again. Without opening the paper, I have extracted the journal information. Right. If you want to find out the frequency, this we have already done in Web of Science database itself using analysis result. But it can also be done using pipexel. Okay? For example, I want to see in which journal has been published lot. Click on whole strings and click start. Okay. So there are two papers that have been published in IEEE transaction on components packing and manufacturing technology, and remaining papers have only one count. Right. So this is regarding the journal title. So let me go back to the original doc file. So this is where the entire data of all the 44 bibliographic data of the 44 journals were available. Right. I can also extract the author information. Right. So author is given as check it out. AU, right? So let me type AU. Okay. So author is being separated by semicolon. So I want any semicolon separated field. Upon that. Right. So first paper is being authored by 4 authors. Uh, okay. Second paper, it has been authored by 1, 2, 3, 4, 5, 6 authors. So like this, I can have the information of all the 44 journals. Okay. Using this data, I can create a co-authorship network. Okay, as I was saying, a co-authorship network, each node will represent the author name, and the author will be connected to another author if they have commonly authored a paper. Am I right? So this data can be used to create a co-authorship network. So how to create that? Let me tell you that. Then yeah, for that you have to do the analysis step. Go with co-occurrence. Click on make pass with via list box. It is asking whether you want to click the frequency. I'm not interested in the frequency. So I'm clicking no. Right. So I have the list. Now I want to create a network file. So what I've done is click on mapping. Let me show you again. Click on mapping, create net file for PageApp, VOS. Okay, these are all the network visualization softwares predominantly used. PageApp, VOS Viewer. We are going to use Jeffy. Okay, so to input into Jeffy, I need this net file. Clicking on that. It is asking, do you want data for directed networks? So this is not a directed network, so I'm clicking no. Right. So I have totally 217 nodes. There are 270 authors, and this represents the edges. Okay, 1, 2, 2. So what it means is author 1 is linked to author 2 with the edge density of 2. Okay, so author 1 is nothing but Faizan J. Faizan J is linked to Harrison with the edge weightage of 2. What it means is Faizan and Harrison are connected because they have co-authored 2 papers together. Clear? So like this we can get the .NET file. So let me show you how to visualize that file in Jeffy. Okay, this is a network visualization software. So I'm going to open yeah. So the .NET file which we got from Pipexel, that is what I'm going to open here. So let me click on open. So it's asking whether it's a directed or undirected network. It's an undirected network, so I'm clicking on that. See, we have 270 nodes and 576 edges. We saw that in Pipexel, right? 217 vertices. Pipexel, let me close this one. I have 217 nodes, and if you count this edges, it will be around 576. Okay. So this is my network. So we are in the overview tab where you can have an overview of the network. If you move to the data library, here you will be having the data which you got from the pixel. Okay, the nodes. So the first node is Faizan, node 2 is Harrison. Okay, we click on the edges, right? So node 1 is connected to node 2, so it's an undirected network. So these ideas are created internally, so we don't have anything to do with it. And the weightage is 2. Okay, so whatever we created in Pipexel, it's simply imported into the Jeffy. Right? Now, if you want to interpret, so this is, you have visualized this data. Now, if you want to interpret that particular data, okay. choose the force atlas layout. So what is force atlas layout is, it will bring the node that has been central to your entire network. The node that connects to other node to a maximum extent, that will be moved to the center position. So that is the beauty of force atlas network. So it's actually a fun thing. You can click on various options and play with it. Yeah. As you can see, most of them are disconnected because only few papers have been co-authored. Only two papers have been co-authored. Very few papers were authored only by one. So that's why there's a huge disconnectivity. Right? But these four authors, they have a higher connection. If you look at here, you click on the text link so that you can see the name of the authors. One second. And you're going to use label adjust so that the label can be clearly read. Yeah. So if you look at the edges, so these authors, they have higher connectivity. Zanzi, Harrison, Belt. So if you are thinking of collaboration, so these authors are very very connected with other authors. As I was saying, this is a very new research domain area. That's why the connectivity is very very less. Uh, Even in this upcoming research domain area, these authors are connected in a more amount compared to others. So if you are thinking about collaboration of your, or if you are stuck in any point, if you want to any help, you can contact these people. Okay, let me show you. Yeah, so this is your co-authorship network, right? So I actually haven't formatted the data. That's why it's looking like this. If I have seen my first slide, so this is one co-authorship network. As you can see, these authors are central to the network. They are more connected compared to other authors. So if you are looking into collaboration, or if you are looking into, if you are stuck at any point you need require help, these authors are much connected with the other authors. Okay? So that is how you construct the co-authorship network. Okay, let us see how we can construct the keyword co-occurrence network. Okay, going back to the pip excel. So I'm using the original doc file. Okay, so we have seen how we are going to extract the journal title, the author information, etc. Now let us see how to extract the keyword and construct the keyword co-occurrence network. Right? Yeah. So I've typed the KW because here the keywords are represented by KW. So I am keeping the any semicolon separated because keywords are separated by semicolon here. Let me prep it. Okay, so this is very useful because Web of Science doesn't provide you the keyword extraction. So we have actually extracted the keywords from each of the 44 paper without even opening the paper. Okay? And another beauty of it is it is available in a Word format. You can open it in Word format and you can easily sorry, yeah, talk right. It's dot out. You click on the dot out. It is, you can extract in the format. And the thing is, before doing any meaningful visualization, you actually have to further process the data. For example, some of the keywords will be in capital letters and some will be in small letter. So when you are trying to find out the frequency, that is when you are trying to map this keyword, it will not map because this is in capital letter and this is in small letter. So before doing the visualization, make sure you have formatted, you have conditioned the normalized the keywords. So for example, here it's fused filament fabrication and in bracket it's triple F. Some other paper it will be just triple F or fused filament fabrication alone. So in such case, you have to change it. Either you can remove this triple F or you can make it all in a small letters. Then only it will be linked to that keyword in that particular thing. Because if it is having a different capital letter, then it will not be linked. Okay. So for processing also it is easier. So if you just open it and you can process it. Also, if you want to extract the abstract, that is also you can do. Okay, I will come back to that. So now I've got the keywords. I can also determine the frequency of the keywords. That is not possible in a Web of Science. So similarly here, old string, sort in the descending order, start. Yeah. So 16 papers have used additive manufacturing keyword. 4 papers have used deposition only. Okay. So this is what I was saying. Only 3 papers have used filament fabrication. Right. So this is all in caps. We actually saw a paper with fused filament fabrication with triple F in bracket. So actually it also meant to that one was missing. You can find that in one. That one was missing because it was in small letters and with triple F, right? So you have to normalize these keywords before you have to normalize these keywords before you are going to use in data visualization. Okay, let me come back to the outside because I want to do co-occurrence analysis. So how to do that is go with analysis, co-occurrence, make pass via list box. I don't want the frequency. Okay, now you have 4 papers that has keywords 3D printing and additive manufacturing. 3 papers that have keywords 3D printing and delivery. Right? Now I'm going to create a .NET file. It's asking whether it's for directed arcs. I'm saying no. Yeah. Finally, we have the network. Right? Shall we open this network in GCE? See, we now have P32 network nodes. So it's undirected. Okay. Yeah. So this is my new network. I'm going to use 4 set 2 algorithm. So this layout will push the nodes that have high connectivity towards the center and these connected networks to the periphery. You can try out these different options. So you can see, so these nodes are, they have very fewer connection with the main network. So they are being pushed out. Okay. So the nodes which have higher connectivity, they move towards the center and the nodes which have lower connectivity, they are moved to the periphery. For further processing, actually what you have to do is you have to remove these nodes because they have no connection with the main network. For example, if you are doing the cluster analysis or the main path analysis or latent analysis, whatever further analytics you're going to do, for that you have to remove these nodes. Okay, that is very easy. You just have to right click and delete it. The thing is you have to do it individually. That is, it's a bit time consuming process. Okay, you can play around and see. You can see how it is being connected and all. Okay. So let me repeat, for having a meaningful interpretation, you have to remove these outliers. Okay. Then only you can get a meaningful data. I have no time to remove it individually. So I'm leaving that to you. Right. Next, I'm going to find out the, I was saying I'm how to cluster it, right? I'll give the technique. First, I'm going to write the eigenvector centrality measure. So what this measure is, it will rank the nodes depending upon how connected it is to other nodes. Okay? The more the number of connections, the higher will be its weightage. So let me, so here is the ranking thing. So I'm going to rank the nodes based on the size. This is coloring and this is size. Okay, size of weight. I'm going to use eigenvector centrality measure. Okay, so the measure is, the size is between 1 to 100. Okay, I'm going to apply that. Yeah. As you can see, these nodes are highly connected and they have larger size because they have more number of connections. Okay, let me expand it further so that it's more visible to you. Okay, so these nodes are highly connected compared to these nodes. Okay, if you want to know what that particular node is, click on it. So this is additive manufacturing, this is 3D printing, this is paste based, this is delivery. I can't get this one. Let me zoom it. Sorry. Don't get what it is. So this is how you can see, like, so this is how they are highly connected compared to other nodes, right? So we have visualized it. Now I want to cluster it. I was saying, right? So we have a really 500 something nodes. I want to cluster it so that I can get the domains or what are the predominant areas that are being studied here. So for clustering, I'm going to use the index modularity. So run modularity. You just look at this value. You have taken resolution as 1. This modularity index, it should be greater than 0.5. Only if it is greater than 0.5, your data is meaningful. Okay, so it is greater than 0.5, but the thing is, I have 19 clusters. So if you have this large number of clusters, it is very difficult to take any meaningful data. So what I'm going to do is, I want to bring down the number of clusters. So in order to bring down the communities, what I'm doing is, I'm going to lower the I'm going to increase the resolution. Let me write the resolution as 5. So the number of communities have come down from 19 to 11, but the modularity is 0.533. That is a good thing. If you want to further bring it down, because 11 is also very high, I'm using 6. Yeah, so modularity is coming down, so I don't prefer this one, so I'm going back to 5. So it means there are 10 individual domains inside this. So 11 individual domains inside this. The thing is, only if you have formatted the data properly, you have normalized the keywords, you have removed the outliers, then only you will be getting a very good data visualization, right? So I'm going to give different colors for the nodes. That is, each cluster will be in different colors. Yeah. So as I was saying, only if you have normalized the data, remove the outliers, you will be getting a meaningful interpretation. Now you can group the nodes with similar colors. Actually, you can change the colors also because only 3 proper colors are visible here. Like this, you can add on more colors. It's actually very good thing. You can explore different options and play around. Right? Now you can group these datas. You can move the nodes separately and these will be the clusters. If you want to know what each of that cluster means, you can click on the label so that you can get the data. Okay. Since it's running out of the time, so this is how I will show you another file where it has been processed, where I used the processed data. Yeah, see, so I've moved the nodes. So yellow nodes, they represent one particular research domain. Red nodes represent particular research domain. Okay, so this is one such thing. Okay. So only if you have removed the outliers and you have processed, conditioned the data, it will be more clear, right? So if you look at, for example, I want to know what this particular domain talks about. Just look at the bigger node with bigger size. So this is supply chain management, firm performance, mediating role, service innovation, environmental practices. So looking at these keywords, you can be clear what they are going to talk about, right? So this is how you do the cluster analysis. Any doubts? I know I'm going fast, but the purpose of this is just to give you overview of what all that can be done here. Similarly, you can also see that forward water network analysis. Yeah, the first slide I showed, right? Yeah. So if you have conditioned the data, if you have removed the outliers and everything, this is how it will look. So going back to my presentation, so I was talking about cluster analysis, right? So this is how I have clustered the RFPN. So I have formed four clusters, but looking at those four clusters, I don't know what the domain they are talking about, because I have only the paper ID. So to get an idea about what they are talking about, I need to do keyword concurrence for each cluster. So by looking at these keywords, it is very clear this domain is talking about stochastic programming. It's a technique, right? Stochastic programming, and the domain is supply chain network design and facility location. So just by looking at these keywords, I can say that this cluster is talking about the supply chain network design, and predominant technique that are being used is stochastic programming. Similarly, if you look at this cluster, it is talking about the disruption risk and supplier selection. So the problem here is supplier selection under disruption risk. So this domain talks entirely about that particular area. And by looking at the outliers, for example, bankruptcy. So these topics have been least addressed. So what happens when your supplier under disruption risk goes bankrupt, and how you are going to reconfigure your network. So that problem has been key studied. So you can have an idea of which are more centrally studied and which are being least studied. Right? So this is how you can determine it. So that is an example of co-occurrence analysis. There are some other way of visualization. Instead of having the edges, you can also have heat map. The red color indicates that the most predominantly studied, and green indicates, or blue indicates least studied. So this visualization has been done using VOS viewer software. That is also very user friendly, similar to Jeffrey. Yeah, coming back to the different analysis techniques. So we have seen clustering analysis. We'll see what are the remaining techniques. I'll just give you an overview. Yeah, strategic diagram. So once you have done the co-occurrence analysis, you can plot the strategic diagram using SPS software. It's a very useful thing to determine what are the developed or saturated area and what are the upcoming and underdeveloped area. Okay. So what happened here is, once you have done the cluster analysis, you are going to place the cluster in this 2D plot. Okay, your x-axis is going to represent centrality. That is how each cluster are connected to the another cluster. So what is the strength with which a cluster 1 is connected to cluster 2? If it is highly connected, it will be having a higher centrality value. And the density, that is y-axis density, indicates inside a cluster how the papers are highly correlated. Okay, so inside a cluster, if I'm talking about the weightage, that is density, and how one cluster is connected to another, uh, that that measure is centrality. You can map this using SBS software. So you have four quadrants. In quadrant 1, if a cluster is placed in quadrant 1, what it actually means is it is very central. That is, it is connected to all other the upcoming domains or the saturated domains, and it is very developed area. So if you are going to publish a paper in that particular domain, the chances very less because the journal will demand novel contribution. So small changes or small contribution cannot make the publication easier. So please don't choose the area that falls under quadrant 1. And quadrant 2 is, yes, it is highly connected, but it is underdeveloped. What I mean is that cluster, for example, cluster 2, it is connected to all other clusters, but the density inside the cluster, the works are very, very less. So what it means is it doesn't have a strong empirical work or strong contribution that it is highly connected. See, that word is being used by all other developed work, okay? But it doesn't have any strong work. So if you contribute here, chances of your paper getting published is very, very high. And the third quadrant, peripheral and developed. So third quadrant, what actually means is it is highly developed. Okay, its density is very, very high, but it is in the periphery. It's an outlier. What it means is once it would have been a very, very developed area or very, very important area, but right now papers being contributing to that is very, very less. So if your work falls under quadrant 3, then the chances of your acceptance is very, very less because it is already developed and saturated and moved out of picture. And the fourth quadrant, yeah, so it is in periphery and it is also underdeveloped. Okay, what it means is very, very few paperworks have been reported in that. It is not at all developed. It has fewer connection within the cluster and it has fewer connection with remaining clusters also. Okay, so if you want to publish a paper, make sure you choose either quadrant 2 or quadrant 4. If you choose quadrant 4, then the chances of paper getting published is very, very high. Yeah. So this is one such example. So this author, he had identified 11 clusters and he had placed the 11 clusters in the 4 quadrants. As you can see, this cluster 3. So if this is a particular domain area, if you are working on that, the chances of your paper getting published is high. But if you are working on quadrant 13, the chances of your paper getting published is very, very high. And if you are working in area 7 and 8, then the chance of the paper getting published is nearer to 0. Right? So what it means is you have to work on data storage area and information storage area. So only if you work on these 2 areas, your paper publication chance will be very, very high. So that is strategic diagram. Next one is main path analysis. Actually, it's a continuation of citation network. If you want to find out which author has contributed to a particular revolutionary ideas, okay, over a period of 25 years, some papers would have contributed, it would have revolutionized particular field. Okay, so this is used to give you a dynamic perspective. So who have contributed the more? That is by getting the citation count. Okay, once you have determined the citation network, the next analysis is main path analysis. So using this analysis, you can determine in which year and which author has revolutionized that particular domain. Okay, this can also be done using SPSS software. Yeah. So latent semantic analysis, this is actually completely different from clustering. Here we will not be clustering the nodes. Here we'll be having a term known as concepts. Instead of clusters, we have concepts. The beauty is each node, it need not be present in only one cluster or one concept. Okay. For example, this keyword wind, it can be in concept 1 and also in concept 2, but with different strength. Okay. So this is concept 1, concept 2 and concept 3. In case of cluster analysis, a particular node can belong to only one cluster, right? But in case of latent semantic analysis, a particular node can belong to more than one concept. That is the beauty of here. Yeah, multi-dimensional scaling. So instead of clusters, here will be having blocks. So B represent blocks. It doesn't give a relationship. For example, once you have done the frequency mapping, that is, you have determined the frequency of the keywords with similar frequency. For example, you have 3 keywords and 3 keywords are in the frequency of 8 to 10. So they will be grouped together as a block. Okay, they have no ties, no other ties. Okay, they are completely unique and completely different. Okay, here we are not seeing whether the same paper has used, whether they have some common papers. Okay, only thing is if they have common frequency, they will be grouped together as a block. Okay, and then they will be placed in a 2-dimensional scaling. Okay, So the x and y axis doesn't have any real meaning, only the distance. Okay, how the block 16 is differing from block 10. The distance will be mapped here. This can also be done using SPSS. Yeah, hierarchical clustering. Here what we have done is, this is one of clustering technique, like how to cluster it. So this is the keywords. This is the keywords and how we are going to cluster it. We are going to cluster it using a tentogram. Okay, for that what you have to do is, look at this vertical lines. The vertical lines with the smaller horizontal line, they will be having closer similarity. For example, this 53 to 72, they will be classified as one cluster. Okay, then 64 to 116, they will be classified as a cluster. So this is one of the technique used to cluster it. Just like we have used modularity, here you are using tentogram to cluster the groups. Right, so this is
excuse me, ma'am.
Yeah.
Sorry for interrupting. Ma'am, could you please wind up this session because we have
Sure.
session
I have only
7:30.
one more slide. So meta-analysis, you will be using the statistical techniques, right? So based upon the findings of 100 papers, you will be applying some statistical techniques, like you will be finding the pooled mean or the p values, and then you will be justifying whether the hypothesis occurs or not. Okay, that is meta-analysis. And yeah, this is coming down. So this is an overview of what are the open source software required for various bibliometric analysis. You can look into that. And right now there are a lot of AI tools. When we were doing systematic literature review, we actually used only these tools and software. But right now there are a lot of AI tools like Research Rapid, Paperpal. So we can also explore that so that it can minimize this huge amount of processing data. Yeah. Any questions? I hope the session was useful.
Ma'am, one of the participants has asked which type of optimization techniques are used in research. Any latest techniques available?
Use any meta heuristics. Okay, like in meta heuristics techniques, you can use MATLAB to code it. As of now, particle swarm optimization, non-dominated genetic algorithm. So if you are having the experimental results, instead of using the standard Trichy and RSM techniques, you can go with meta heuristics. There are a lot of huge meta heuristics, and the coding is also available in online. You can also use any AI to also Perplexity and ChatGPT to create the MATLAB code. So any meta heuristics, if you are using it, then the chance of your paper getting published will be very, very high. Recently, I used teaching learning based optimization technique, and the paper got good acceptance.
Madam.
Yeah, WS is a free subscription. Only thing is you have to log in from your institution ID. Yeah.
This scientometric analysis can do by using viewer and
Yeah. Vivo is just like Jeffy. You can get the .NET file from Webexcel. Then you can, instead of using Jeffy, you can go with the Vivo's viewer page app. They also have the same application.
Okay. Can we download those freely?
Yeah, they are all open source software. Whatever I've used and whatever I gave back, they are open source.
Okay. Jeffy also.
Jeffy is open source.
Okay. All those software.
I will share you my PPT. In PPT, I have given what are the alternative tools also. Everything is open source.
Okay. Thank you.
Any software for optimization? I use MATLAB. Okay, most of the coding is available in online. For example, if I want to use a particular cuckoo optimization, I just have to search that code. Okay, then just copy and paste it, modify it for my problem, and then use MATLAB. I use MATLAB, but recent researchers of my friends, they are using Python, but I use MATLAB. In MATLAB, don't use the MATLAB toolbox. You just create the code.